So good evening everyone and welcome to this lecture. We were dealing with wave optics and we were seeing what do you mean by interference, and we had seen the two types of interference. I think do you remember constructive interference and destructive interference? In constructive interference we have maximum intensity and we have maximum amplitude. You must remember the formula for both of these. Maximum amplitude is A1 plus A2 and maximum intensity is root over I1 plus root over I2 whole square. Everyone remembers this? This is for constructive interference. Yes or no?
Yes, sir.
Then we had a destructive interference, and for destructive interference, we have minimum value as A1 minus A2 for amplitude. Minimum for amplitude, minimum intensity was root over I1 minus root over I2 whole square. Yes or no?
Yes, sir.
Okay, we had finished this class here. What we are going to do is just take it a step further, and if I take a special case here, say for example, if I say that if A1 and A2 are both equal to A0, both are same, and these are the questions that come in your NEET exams very often, A1 and A2 both are same and that is equal to A0, then your maximum intensity will become how much? It will become 2 times A0. Yes or no? And your maximum intensity will become how much? It will become 4 times I0. So remember this. Do we understand how we have got this? I've just put in place of A1 and A2, I have put A0, and in place of I1 and I2, I have put I0. Do we understand this?
Yes, sir.
Similarly, if I go on this side, if A1 is equal to A2 is equal to A0 here, your minimum intensity will become 0. Your minimum amplitude will also become 0. And that is the point where we say that the interference is sharp. Where you have destructive interference, you will have zero intensity. Zero intensity means it will be dark, very dark, almost dark. Maximum intensity will be 4 times I0. It will be very bright. So to have good interference, we must have both the amplitudes exactly same. If both the amplitudes are exactly same, minimum intensity becomes 0, very dark, and maximum intensity becomes very bright. Do we understand this? That is what we say, very good interference. For very good interference to happen, the amplitudes must be almost equal. Do we understand this? I'll
Yes,
give you
sir.
1 minute to note this down. These are the small points that come in your exam. So please remember it. I'll give you a lot of these short forms, shortcuts, important points. The same points are going to appear in your exam. So please note them down very carefully. I'll give you 2 minutes to do this.
Done, sir.
What about the other class? Everyone done, beta?
1 minute, sir.
Yes. So please, once both of you are done, I need to hear two voices, two different voices, so that I am sure that both the classes are doing it and they have done it.
Completed, sir.
Well done, bacha. If you have completed this, then we will move ahead and again we will move on to some important points and some special cases, and these special cases are the ones that are going to come in your exam. These are the questions that come in your exam. So please write them carefully without doing any mistake. And remember, you can obviously solve these questions in the examination hall, but if you remember them, and you can make small notes of them. I will did I send you that short notes for ray optics? I put it in the group. You got it, no? That thing I had put in your group. Let me check. Else I will put it. I put something in your group. Where is this group? BIPC. This is here. I had put some notes. See, I had put some mind map for your revision, and I will put some summary of notes also probably there. Maybe I'll put it today. These are very precise notes covering almost everything. It's there in your group. I hope you have access to your group. Else you can ask the office people that they will take a printout of this and they will give it to you. I'll ask them to, if not possible for you to have a look at in the group, I will ask them to take a printout of this and they will share it in the, will give you hard copies of that. So you have to note all these small points, because all of these points may not be there in those mind maps, because they are very what should I say, they tell you everything, but they tell you everything in short, so every point may not be there, and that is why you need to be careful and note all these points. And when you get all these important points, put it on a piece of paper, put it in front of your desk. I hope you have a desk right now. Here I've also put a lot of things on my desk that keep me reminding of what I have to do, what I have to teach in this class, what I need to teach in that class. Sometimes I'll show you from the back of this what all I have on my wall. You also do the same thing. The next heading that I'm going to do is again very exam centric, so please be very careful. Result and intensity for identical waves. When I say identical waves, what I mean is my A1 is equal to A2 is equal to A0, or I can say my intensity I1 is equal to I2 is equal to I0. Do we understand this? Now remember, a question can be a general question which does not have same intensity. I will give you that question as well. A question can be a special question where the intensities are same. No matter what the case be, I must always remember this formula for intensity, and this is the formula that comes in your exam almost every time. We remember this formula of intensity, I is equal to I1 plus I2 plus 2 times root over I1 I2 cos phi, where phi is the phase difference between the two waves. Yes or no? Now if I put in this formula I1 I2 same as I0 and do some simple maths, I will land up with this formula, which I'm not going to tell you how we are going to get it, but I'll just tell you the result. This is the result that you should remember. Cos square phi by 2 is half angle. So if phi is 60, phi by 2 becomes 30. Do we understand this? If phi is 90, phi by 2 becomes 45. That is all that is needed for you to remember. But again, this formula is only valid if I1 is equal to I2 is equal to I0. Remember, it's a very important formula that you should never forget. But it is only valid when I1 and I2 both are equal and same as I0. Having said that, have you noted this formula?
Yes, sir.
Okay. Now, again, all these important points we will keep on noting. Sometimes they ask you about the average intensity. Average intensity. I've seen it coming in some of your papers. Average intensity. Now, when they ask about average intensity, how do I write average intensity? I in this bracket. Average intensity I in this bracket. The formula for average intensity is this. Please remember it. This is I min plus I max by 2. This is one way of remembering it. If you put the value of I max and you put the value of I min and divide it by 2, you will get this I1 plus I2, or you can write it as A1 square plus A2 square because it is proportional to this. Do we understand this?
Yes, sir.
All the formulas I am noting down one by one. Any one of this can appear. Then we have one thing which is known as ratio of maximum to minimum intensity. I max divided by I min. So I max divided by I min will be equal to what? Everyone knows this. The value of I max. Everyone knows the value of I min. I max is I1 root over I1 plus root over I2 ka whole square divided by root over I1 minus root over I2 whole square. You can remember it in this way, or you can remember it in this way, A1 minus, A1 plus A2 whole square divided by A1 minus A2 whole square. I hope everyone is noting this down. One more thing that I have seen in your exam, and I will tell you that thing as well. Sometimes they give you slit width. What do you mean by slit width? Now, in Young's double slit experiment, we are going to have slits. Slit is nothing but a small hole, opening, pinhole. That's a slit. If the slit is very small, see, if this slit, this hole is very small, very less light will come out of it. If it is very large, more light will come out of it. So that is how I remember it. The slit is the intensity of wave is directly proportional to the slit width, and it is equal to amplitude 1 square divided by amplitude 2 square. I remember it in this way, beta. Intensity is directly proportional to your slit width, and your slit width is directly proportional to your A square. A standing for the amplitude of the waves. Do we understand this? So these are the
Yes, sir.
small formulas that if you can remember, that will help you a lot in solving any questions. And I will now present to you one or two questions. If you can do those questions, that means you are doing pretty well. Have you noted this down?
Yes, sir.
Then
Yes,
comes
sir.
then comes the first question, pretty simple one. Remember the formula, put the formula, get the answer, and stay happy. Two waves are represented by y is 4 sine omega t, y2 is 3 sine omega t plus pi by 3. Pi by 3 means 60 degrees. Interfere at a point, find the amplitude or resultant wave. You have 2 minutes to solve this.
Sir,
Yes, bacha?
sir, under root 37.
Under root 37, that is correct, beta. Under root 37, that is correct. What about the others? Are we able to do this? Well done. Under root 37, if you remember simple things, life becomes simple. Everyone got this? Yes or no? No, yes. Got it. What about the other class, beta? I'm waiting for your answers. Still not got your answer, so I'll wait for 1 more minute. One more minute, I'm waiting. Can anyone tell me how you have done this, bacha? Tell me, beta. You have done this, how you have done this?
Sir, A equals to under root A1 square plus A2 square plus 2 A1 A2 cos phi.
That is correct. Then
We need to substitute the values in that, then we will
we
get the
need to
answer.
substitute the values, and that is what we got to do. Just remember the formula. Formula of resultant amplitude is definitely A1 square plus A2 square plus 2 times A1 A2 cos of phi, and we take the square root of this entire thing. A1, the first amplitude is 4. A2, the second amplitude is 3. And this angle phi is the phase difference. It is pi by 3. You just put the values, get the answer, and stay happy. So it will be under root of 4 square plus 3 square plus 2 times 4 multiplied by 3 into cos of 60 degrees. Cos of 60 is half. You can multiply, divide, get the answer, and I think it will be under root of 37. Everyone got this? Yes or no? Can I have raise hands from everyone?
Yes, sir.
Well done. See, things are pretty simple if you understand them, and you can have a similar question coming. The values may not be same, but I'm sure that the question would be same if it comes. Can you move on to the next one? Everyone,
Yes, sir.
remember, just remember these formulas correctly. We will do a lot of good things. And here comes the next one in this category. Two beams. Two beams of light having intensities I and 4I. Remember, they don't have the same intensity. One of the waves has intensity I, the other wave has intensity 4I. Interfere to produce a fringe pattern. What do you mean by a fringe pattern? We don't know, but we will get to know about it. It's just a term. Let it leave it. The phase difference is, okay, pi by 2 at point A. So at point A, it is pi by 2. 2 pi is 360 degrees at point B. Find out the difference between the resultant intensities at A and B. Read the question carefully, solve it, get the answer, stay happy. I'll give you 2 minutes to do this. Anyone with any answer? Shall I do it, bacha?
So 1 minute.
Okay.
Sir,
Yes, bacha.
4i.
You have to find out the difference between the intensities at A and B. Have you done the same thing? 4i is correct. I think 4i is correct. Well done. What about the others? Are we able to do this? I see a very vast improvement in the way you are solving the questions, and that is very heartening. I'm very impressed. Well done, everyone. We are doing some things correct, that means. But I will give the other students also a chance to solve the question themselves. I'll give them a minute. 1 minute. A minute to win it. Let's see if we can have some more correct answers from. Answer is 4i. Abhiram, well done. Very well done. That is correct. That is absolutely correct. No questions asked, no answers given. This is absolutely correct. What about the students from the other class, bacha? I'm not hearing any noises from your end. I hope everything is fine. Yes or no? No, yes.
Yes, sir.
Everything is fine. That means
Yes, sir. We got it.
you got the answer or not. Fine means
Got it, sir.
well done. That means everyone has got this. That is very nice. So, how do you do it? Anyone would like to tell me how it is done? I would be very happy if anyone tell me how it is done. I don't know. I have no idea how it is done. Yes, tell me how it is done.
Sir, I equals to
Uh,
I1 plus I2
let's
plus
speak slowly now. My brain is not so fast. You are fast. My brain is not. So I is equal to yes.
I1 plus I2 plus 2
I2 plus
into under root I1 into I2 cos phi.
cos phi. Now what do? I just see what are the values given. My I1 is given as I, yes or no?
Yes, sir.
And my I2 is given as 4i.
4i.
That's it. I have put the values. Let us find it for I at point A. So I put I plus 4i plus 2 times root over I multiplied by 4i multiplied by cos of phi. Phi at point A is pi by 2. Cos pi by 2 you all know is 0. So your answer for this case is simply 5i.
5i.
Then I repeat the same thing for intensity at point B. It will be I plus 4i plus 2 times root over I into 4i multiplied by cos of 2 pi. Cos of 2 pi is cos of 360. Cos of 360 is plus 1. 1 into 2 is 2. 2 into root over 4i naught square is 2 into 2, 4. 4 plus 5 is 9. Everyone got 9i?
Yes, sir.
A simple multiplication. After this, it is very simple. They have asked me to find out the difference. So I find out the difference. How do I find out the difference? I subtract the smaller one from the bigger one. and I get the answer as 4i. That is the answer. Everyone got this, yes or no?
Yes, sir.
Well done, swiftly done. You have not taken so much of time. Good. That is good. That compels me to do this one as well. And let us see if you can do this one. Remember, this is more a question of maths. And when I say maths, it is 8, 9, 10 standard maths. Then physics. Physics is just one step. If you can do this, well done. Question number 3. In interference pattern, if the slit widths are in the ratio 1:9, find out the ratio of, remember which ratio they're asking, minimum and maximum intensity. Simple question. I'll give you 2 minutes to solve this.
Sir.
Yes, bacha. 1:4. Abhiram has given me the answer, and that is the correct one. Well done, bacha. 1:4 is correct. Well done, beta. What about the others? My other students? Huh? I'll give you 2 minutes. Don't worry. 4/16 is correct, Abhiram. No questions asked, no answers given. That is correct. That is absolutely correct, as correct as it can be. But I shall give everyone chance to redeem. Yes, my dear friends. It's simple. What about the other students in the other class? You still have time to redeem yourself. Students are like cash vouchers. Sometimes they might not apply, but if they are good cash vouchers, you can redeem. By redemption, I mean that you can do the question. If you can't do a simple one, you can do the next one, which might be more difficult. You redeem yourself. Redemption. I think this is the time for me to solve the question. Aviram, how did you do it? Tell me. I hope you can unmute yourself. Not working mic. Okay.
So
Technical
can I
problem.
try?
Yes. Trials are always welcome. You go to a shop, you buy something, you try, and then only you buy it. Yes. Tell me. Trials are always good. Hmm.
So I1 by I2 equals to omega 1 by omega 2 equals to A1 square by A2 square.
I1 by I2 is not omega, is width, W1 by W2. Okay, you can call it omega, not a problem. Is equal to A1 square by A2 square, and that is given as how much?
1 by 3, sir.
1 by 9. A1 square by A2 square is 1 by 9, not 1 by 3. Okay, so from there I can get A1 by A2.
A1 by A2 is 1 by 3, sir.
A1 by A2 is 1 by 3. Then I can get from here A2 is 3 times A1. Yes or no? No, yes. This is the
Yes,
first
sir.
step that we get. After that, it is very simple, my dear friends, because now they are asking me the ratio of I min by I max. And we already know I min by I max is A1 minus A2 whole square. Remember, it is min by max, not max by min. Divided by A1 plus A2 whole square. So I can put A2 as 3 times A1 minus 3 times A1. If you don't want to write like this, you should write 3A1 minus A1. It's always bigger minus the smaller one. Square divided by A1 plus 3 times A1 whole square. Now, once you do this, you will get 4 by 16, and that will be 1:4. Everyone got this? Yes or no?
Yes, sir.
That's the answer, my dear friends. That's the answer that we were looking at. So I think we have done enough of these questions, and I hope you have got a hang of this. I have already shown you the important points, which I hope that you can remember for these questions. These were those important points that we have used here. Remember them, and this is the general formula of intensity that you must remember. That takes us to the main heading of this chapter. Whenever we think about wave optics, whenever someone utters the word wave optics, the first and the only thing that comes to anyone's mind is what? It's not this. This is wave. What is the first thing that comes to our mind when anyone talks about wave optics? The first and the only one thing that comes to our mind when we talk about wave optics is what? This YDSE, Young's double slit experiment. That takes us to this final part of this chapter. No, this is not the final part of the chapter, because wave optics does not only include YDSE, it also includes some other things that we will be covering in the next classes. YDSE. Everyone heard about YDSE? Huh? Young's, name of the scientist. Double two slit hole experiment. Young's double slit experiment. You might have done this experiment or probably would do it in your 12th standard. How does it look like? It looks very simple, like this. These are the two views that I can show, and I'll show you more of those views. So what do we have is this gentleman. Let me make this gentleman bigger. Okay, so what do we have is this gentleman. Now, first of all, the first thing that I'm going to ask, we are going to produce two coherent sources here. Can you see those two coherent sources that we have produced? We have produced two coherent sources here. What are those two coherent sources that we have produced? What are the names? Can you see them on the this?
S1 and S2, sir.
S1 and S2 are the two coherent sources which are produced. Which source has produced these coherent sources? You can call them as daughter sources. You have a parent source or a mother source. What is the mother source? This sodium lamp. or you can say this slit S is your mother source, that is your one source, a single source of light producing two coherent sources. By which method? Remember, we had two methods of creating coherent sources from a single source. Which method we have employed here? Which method we have employed here? Huh? Which method we have employed here? There were two methods. Do you remember, or have you forgotten the two methods? Forgotten? See? Not good. The thing is, I've got a time machine and I can take you back in time. So back in time we go to the previous class, and these were the two methods that we had seen. The first one was known as
Division of wavefront.
and the second one was known as
Division of amplitude.
in this particular case, which method have we employed?
Division of
wave, sir.
Not wave, division of wavefront. As you can see, my dear friends, this is the parent or the mother wavefront, and this mother give rise to two daughters, daughter number one, and this is daughter number two. Do you see this? One wavefront producing two wavefronts, mother, daughter. Okay, so we have one source which is producing two source, and then we have this gentleman which is lying here, and this gentleman is a screen. So we see what is happening on the screen. What is going to happen on the screen? These two wavefronts or these two waves will fall on the screen and they will interfere. Do we understand this? Yes or no? They will fall
Yes, sir.
on the wave. Fall on the wave. They will fall on the screen and they would interfere. And if I show you a 3D view of this, it would look like this. And I'll show you more views. You may not have to draw them. You just have to see. And this is a good 3D view of what is happening here. I hope you understand. This is my mother slit. These are my daughters, S1 and S2, two coherent sources separated by a distance d. And then I have this gentleman screen here, and we have this pattern that comes on this screen because of interference of the two daughter waves. This is interference pattern, and you see some black lines and you see some white lines. These black lines, and let me mark them with black, these black lines are known as dark fringes. These black lines are known as dark fringes. So you have darkness at some points. You can see this. And then you have the brighter aspect, the white lines. You see these white lines. All these white lines. Oh, I've marked a black one. All these. Oh, why am I marking black lines and calling them white lines? All these white ones. 1, 2, 3. All these white lines are known as bright fringes. Do we understand this, or this has gone above our head saying bye bye? Bye bye, I'm going. So these two daughter waves, they will interfere on the screen, and you have an interference pattern formed on the screen. In fact, you will have alternate dark fringes and alternate bright fringes on the screen. This is known as your Young's double slit experiment. Do we understand this? Yes or no? No, yes.
Yes, sir.
You will have alternate dark and bright fringes formed on the screen, and this is known as your interference pattern on the screen. And I'll show you one diagram, and this is the diagram that you must draw so that you understand, because all this way just to make you understand. This is the diagram that you can draw that will make you understand what is happening here. Because if you don't understand what is happening here, what will you do? So again, this is the side view of the same thing. Comes on your screen now. This is what you are supposed to draw. Everything is mentioned over here. What do we have here? This is my mother source. This is my mother source. These are the two daughters that I produced from that mother. These daughters or these the other two slits are separated by a distance d, small d. It is known as small d. Then you have this gentleman, the screen gentleman sitting here. The screen gentleman is at a distance of capital D from the daughter's slit. Then you have an interference pattern coming on the screen, and you can see this first one, this blue one. Oh, why I am using blue? I could use a bright color. This yellow one. This yellow one is the first one. It comes exactly at the center. This is known as central bright fringe or central maxima. Do we understand this? Now, the central
Yes, sir.
maxima, my dear friends, is what? Surrounded by the minimas. You see the minimas. That this is not visible. This is the first dark on the upper side. This is first dark on the lower side. Then we have your first bright fringe, which is the yellow one. Then you have your second dark fringe, which is the pink one, and so on. Do we understand this, or this has gone above our head saying, bye bye, I'm going? Alternate dark and bright fringes you will get. Central one is always your maxima. This is known as central maxima or central bright fringe. I'll give you 2 minutes to note this now.
Done, sir.
Done, sir.
Okay, then I will move ahead and give you some important points, and you must note these important points and keep them with you. Now, when you talk about interference, what do you see it? At some points you have constructive interference, and some points you have destructive interference. Can you tell me what are the points where you are having constructive interference and what are the points where you are having destructive interference? Huh? What are the points where you are having constructive interference? What are the points that you are having destructive interference? Just do some common sense. Tell me, what are the points where you are having constructive interference? What are the points where you are having destructive interference? No one? All these points where you have bright fringes, the yellow ones, all these points where you have bright fringes, these are the points where you are having
constructed
constructive interference. All these are constructive interference. Dark points, bright points. What about the other gentlemen? Wherever there is brightness, there is
destructive.
darkness. Darkness. All these points where you have darkness, these are the points where you are having the other gentlemen, the destructive interference. Do we understand this? Yes or no?
Yes, sir.
So basically what is happening at some points you have constructive, intensity is maximum. At some points you have destructive, intensity is minimum. So we can call interference as a redistribution of energy. In interference, what happens is energy is redistributed. Energy of the wave is redistributed. Energy of the wave is redistributed. In dark regions, the energy becomes zero, intensity becomes zero, but in bright regions, it becomes very bright. Energy is redistributed and energy is conserved. That means the energy is not lost. Whatever energy we had with the mother and the daughter, the same energy is on the screen. The only thing is it is redistributed. At some points you have more energy, at some points you have less energy. Do we understand this? Yes or no?
Yes, sir.
The second point, you must remember all these are potential questions that are going to come. If one of the slits is covered, what will happen? Will you observe an interference pattern? Will you observe an interference pattern? Important points. No interference is observed. That means we need at least two coherent sources to produce interference. Do we understand this?
Yes, sir.
Many a times, and we will understand this in the coming next class. Normally for interference, we will use a monochromatic light. What do you mean by a monochromatic light? A light which only has one color, yellow, blue, green. One color means one wavelength. To have good interference, we need monochromatic light. But if we use white light, which you have in your room and I also have in my room. Now the white light does not consist of one color. Do we know this? It consists of 7 different colors. Okay, this is 7 different colors. So if I use white light, fringes will be colored and it will be of unequal width. What we will do is we will cover this point in the next class. Here, when you see the fringes, we call these dark and bright things that we get is fringes. All of them are of equal width. Do we understand this? Equal width? The width of this and the width of any bright fringe, they are equal. Everything is equal. But if you use white light, and we will probably understand it in the next class when we talk about fringe width. We will talk about fringe width, don't worry. So we will understand it there, why this happens. But right now, I might forget to give it to you. So you write it. If white light is used as the parent source, because white light does not consist of a single color. If white light is used as a parent source, then you must remember fringes will be colored and of unequal width. Fringes will be colored and they will be of unequal width. The question that has come in your NEET. Central fringe will be white. All the colors mixed together becomes white. The wavelength of the violet color is least, and you will see the relation between wavelength. So the fringe nearest to either side of the central white fringe is violet. So the nearest one would be violet and the farthest one would be red. Just remember this. It is because of the wavelength of the light. Wavelength of violet is the least, so it is nearest. Wavelength of red is largest, so it is farthest. We'll see all more important points in the next class. We will try to wind up this Young's double slit experiment by the next class, because we just have to see 2 or 3 formulas and we are done. So we finished this class here. I hope you have understood what we have done in this class. We will move ahead with the same thing, more points in the next class. Take care. Have a nice day and God bless you all. If you have any doubts, you can ask me.